Oh, look, there's my little head in the screen. This will be fun. All right, so let's start a new topic. We have been on physical layer. This was layer 1. I did just talk about the layout stuff. They call that layer 0 sometimes. The cool kids anyway, or some kids. Apparently that's what they call it at ODU. I had never heard of it before I heard it last semester. Starting here, we are going to talk about Ethernet. All right? This is layer 2. It is a, what's layer 2 called? There we go. Data link layer protocol. All right? And I want to note about Ethernet also is it has physical layer requirements. And we will talk about a few of those as we go along. Okay? But we mostly talked about propagation effects and things like that. We did look at some connectors and cable types and etc. But at Ethernet, when you're talking about the layer 2, remember these are the people that generate the signals, and they need to be able to have it go over a certain physical layer. Right? Ethernet is dominant. Anytime you're on the LAN, you are going to pretty much be Ethernet. I don't know, we'll call this 99+%, okay? There's not even any competitors here, and that's why when I was telling you about when you talked about token ring in IT 201, there wasn't a lot of point to it, because you're not going to see it. It's just not there, okay? Ethernet rules everywhere. On the WAN side, there's other stuff. We might talk a little bit about that, but we're not going to get into it too much. All right? Ethernet was invented by a guy. And you guys need to get used to who the celebrities are. I'd love to hear that static. One of the big celebrities in telecom is a guy named Bob Metcalfe. Okay? You guys hear like the inventor of the World Wide Web, and there's the guy that invented some of these other protocols. Bob Metcalfe is really cool. Well, I don't know, cool, but celebrity, okay? Invented by Bob Metcalfe and you may have heard of this, there's a place called Xerox, P-A-R-C, which stands for Palo Alto Research Center. Has anyone ever heard of that? PARC? Why does PARC sound familiar? Why does the Palo Alto Retail? You've just heard of it? I'm glad you've sort of heard of it. This is where the GUI was developed. And a big famous story is how the GUI was developed there by Xerox people, and one of the big things that Apple did was Steve Jobs went and visited and got the idea for the Macintosh there. And then, I don't know, people knew about it, but that was where it was developed. So the Palo Alto Research Center is also where Ethernet was invented. So now that you're going to be a telecom nerd, we don't care about graphical user interfaces. We care about Ethernet, all right? This is run by, or I guess the standard we shall say, is taken over by the IEEE. So the I and then 3 E's. I don't know what that stands for, I'm sorry. It's just IEEE to me. Somewhere in here is electrical engineers, and it might be I for Institute. I don't know what the third E would be, but anyway. So the IEEE runs it, and they have subcommittees, all right? So there is an 802 committee. And that one works on LAN/MAN standards. MAN stands for metropolitan area. So this is fairly short distance standards, okay? 802 committee. You may have heard of one of the subcommittees. The 802.11 committee works on what? Wireless. This is the wireless. Okay? So that's just what you see. I just want you guys to recognize where this stuff is coming from. The wired people is 802.3. Okay. So this is closed media Ethernet. By the way, this is Ethernet. This is closed media Ethernet. So 802.3 handles all the issues about copper and fiber Ethernet. This is the wireless Ethernet people. This one obviously is a little more active these days, but the 802.3 folks are still working on stuff. Right now they're pretty close, I think, to finalizing 100 gigabit Ethernet. 802.11 AC, I didn't even know they were working on it. And then boom, there it was. Welcome to the club. But anyway, this is where it comes from. So the 802 committee. So this is where the standard is set. We'll just say they're ratified. What usually happens with these committees is someone comes to them and they say, I've got this great new technology, I would like it to be recognized as a standard. And so they work on the standard and they decide if they want to use it as a standard, and then they ratify it. So anyway, so it's a standard and it's ratified. I don't have enough room right here, so I'm going to flip over because I need to draw a pretty little diagram. All right, the first Ethernet. So we're going back to Bob Metcalfe. He would draw a lovely diagram. I'm going to have to get some more colors out. Draw this lovely diagram. And you'd have this cable like this. And you have these ends on it. Okay? All right, this cable is the ether. Did he put both of it in quotes? Oh, it's all right. All right. So that is the ether. And what we called it was the frozen yellow garden hose. This is more trivia for you. Frozen yellow garden hose. The reason why it was called the garden hose was that's about how big it was. It was a coaxial cable, and it was colored yellow. The reason why you called it frozen is because it would hardly bend. So that's why, like this corner, I don't draw a sharp line. You just kind of had to bend it around. Okay. This cable needed to go pretty close to whoever needed to connect to your network. All right. So I might have, some people connected in here. And I'll just draw them in. So I got a couple people connected in here. And I'm going to draw this in as if it's a little triangle connected in. Because what you had, if I zoom in here, is there was a little, I don't know if I can draw this very well. There's a little pointy edged thing. Let me draw the cable. So if I draw my coaxial cable here, what I needed to do is take a drill and drill a hole. I drill a hole that goes all the way to the center. And then I have this thing that has a connection point on the center, and then on the sides they're connected to. Okay? So I need to have one thing connect to the center, and then another set of wires connect to the side. And then in between is like this insulation stuff. Drill hole to center, and then I pound in a pointy thing. I'm just not going to get too much worried about it. So it had a point on the end of it, and you pounded it in. This is called a tap. You guys ever heard of a tap before? What other things do you tap? Oh, that's just like drip irrigation. Wow, that is a really good one. It is almost exactly like drip irrigation. Like when you tap a beer keg, you actually, on a wooden beer keg, there's a sharp thing that you actually literally pound in with a hammer, and you actually had to pound it in. Sorry. So this was a tap, and anyway. So you pounded it in until it hit that center. This was fun times of networking, okay? And so what would happen is if anyone wanted to send a signal in, so let's number these as like A, B, and C. And so let's say A wants to send a message, and we've been through bus topology, right? when A wants to send something in, it goes through the whole wire. And we understand it propagates, right? We remember propagation. Both of them hear it. C actually processes it and B doesn't, all right? So the idea of Ethernet was, it was simple. We'll just put a bus network and a rule of, we'll just say we ignore traffic to Fs, not for me. So I'm going to ignore any traffic that belongs to someone else. I just ignore it. And then, before I transmit, I'm going to listen to hear if the, and we'll put our quotes on the ether, is free. So if no one's transmitting, I'm going to listen for the ether. Okay? Is the ether free or not? We call this carrier sense. Okay? So we're listening for what's called a carrier. And you don't need to worry about that. It has to do with these terminators on the end, and it should have a certain voltage in it. So if I kind of listen in on the voltage, it'll be this constant voltage. When I add my signal, the voltage will change. All right? The next thing I need to do is, while I'm signaling, did I say that? Yep. While signaling, listen for, we'll just say, interference. All right? So the whole time I'm signaling, I'm going to listen to hear if someone else is starting to transmit at the same time. I'm explaining this now because this is more important when we get to wireless. We call this collision detection. All right? Well, it has other issues now. So you understand here, while A is transmitting, A is going to still sit and listen to the cable, because A wants to hear that its signal is okay. The whole time I'm signaling, I want to hear that everything is working okay. Because if someone all of a sudden else tries to transmit, I've run out of colors. They need to get me more colors in here. Anyway, so if B suddenly starts to transmit at the same time, it should hear a collision. Okay, so A should hear that there's a collision. Are we nice here? So there's a carrier sense. We listen to hear if the cable's empty, and we listen to hear if our signal gets interfered with, and that's a collision. All right, that's awesome. So that's the basic idea of Ethernet when I want to send my messages. Now let's get into some specifics.